Hello grade 12s, welcome to my channel, and let's look at another question. It was by request, and essentially the main question on this was also on the last question, which spoke about transformations, which in this case is essentially a translation. So we're going to get to it at the end of our lesson. So let's solve this question by question and give you some skills that you need to go through questions of this nature. So in this question, we are given a diagram where the circle with center O. Now, center the origin will always have an equation in this format, okay? So x squared plus y squared equals 20. Then G with coordinates t and 0 is the center of the larger circle. Great. Now a common tangent, so this is very important. A common tangent touches the circles at D and F respectively, such that D with coordinates p and -2 lies in the fourth quadrant. So this is also key to notice. So what does that mean about coordinates of D? If P is to -2, we know that P should literally be a positive answer. Why do I know it should be a positive answer? It's because P is in the fourth quadrant. The x coordinate for any point in the fourth quadrant is positive because it's on the positive x-axis. So that's the significance of most of the information we are given. And what else do we know? We know that if this line DF is a tangent, let's put it in black. So it means this line is going to be perpendicular to OD, the radius of the smaller circle. Likewise, it should also be perpendicular to the radius of the larger circle, because a tangent is always perpendicular to the radius of any circle it touches. Now, if you notice here, we've got two alternate angles that are both equal. So it suggests that these lines are essentially parallel to each other. Okay. So these are the things you need to kind of get in the habit of doing, analyzing the sketch and trying to see how you could work out certain things. Helps you by providing you more options in solving some technical questions that you probably may not have enough already given, but it's actually suggested or implied. Now let's have a look here. What can we do? We know that points D, we only have one unknown P, and we've got the full equation of the circle on which D lies. So we can substitute D into that equation. We can get the value of P. That means we'll have the full coordinates of D. From there, we can use the property that OD is perpendicular to DF to work out the gradient of DF and use the coordinates of D to find the equation of that line. As for E and F and G, we really don't have enough information to work this out. But actually we do. We can actually work G, since we have realized that these two lines are parallel. Okay, we know that the gradient of OD is going to be equal to the gradient of FG. No, we can't find because we don't know the coordinates of F. So our limiting factor will be F. So this simply means we need more information to work out perhaps point F, G, and E. Okay, but if you skim and scan in the questions below, you'll almost always find extra information provided to work through the next problem, should it need E or F to be looked at. So we appreciate that we don't have enough, but we trust that they will provide us enough. But at least we've done our brainstorming pretty well. So let's get to the questions as quickly as we can. So we are doing question 5 Now, not 5, I'm in dreamland, okay. So 4.1, we are told here, given that D with coordinates p and minus 2 lies on the smaller circle, show that p is 4. Can you see, when we are told to show, we need to work out everything in full display. So we know that literally circle with center the origin is such that x squared plus y squared is equal to 20. Now with point D with p and minus 2 lying on this, we will substitute those values to work out the unknown. This implies that we've got p squared plus 4 is equal to 20, which also implies that p squared is equal to 16. Then we do our gymnastics of choice. Is it of choice? Okay, whatever. Then we can make a conclusion that p should be a plus 4. Why are we choosing a plus 4? Because we were told that point D is a point in the 4th quadrant, so the x coordinate should be positive. So usually we get a mark for correct substitutions and the final answer. Even though this answer was given, the fact that when we take the square root, we are supposed to take a plus or minus. Now selecting the positive answer is mark worthy, so we are getting a mark despite repeating what we have been given already. Let's move on to 4.2. 4.2 says E with coordinates 6 and 2. Now, this is giving us the good vibes because we needed extra information. In fact, we can update those coordinates now. This is 4 and minus 2. Okay. So we are told that E with those coordinates is the midpoint of DF. Now we are to determine the coordinates of F. So you can see with extra information it becomes easy to proceed. So we know that point F is such that x at F plus x at D is over 2 should give us the x at point E, the midpoint, plus y at F minus y at D, is it minus? No, plus, divided by 2 should give us the x coordinate, not x but y, at even okay, so this implies that our F is, we substitute, we still want the x at F. This is plus 4 over 2 is equal to 6. Y at F minus 2 over 2 is equal to 2. Then we can make our final conclusion. We then just cross multiply the 2 to 6. We get 12. 12 minus 4, we get 8. Then we do the same here. We cross multiply the 2, we get 4. We transpose 2, it becomes 6. Alright, so that's what we do. So how many marks here? 3 marks. Perhaps correct substitutions, and then for those individual coordinates. So this is as straightforward as that. Nothing really fancy there. So 4.3. We are told here, we can update F here. This is 8 and 6. Essentially, always easy questions, you need to interrogate your answers in case you're making a mistake. Look at point F, for example. Point F is literally higher than the points E and D, since they are collinear on DF. So this means point F should have a higher Y value than those two other points, and it is so. Again, this is a slanted line. It suggests that F is ahead of these 2 points horizontally. So it should have a greater X value than the other two, and it is the case. So we are satisfied with the way our answer came out. Now let's do 4.3. It says determine the equation of the common tangent DF in the standard linear format. Okay. This is easy. We can use the property of the tangent and the radius. So we know that the gradient of DF, our tangent, multiplied by the gradient of OD, the radius of the smaller circle, should give us -1. The reason here is that our tangent is always perpendicular to the radius at the point of tangent C to any circle it touches. Alright, so this implies that the gradient of DF into, now we can choose how we're going to work this out. We can choose point D as -2 minus 0 over 4 minus 0 at the origin is equal to -1. We simplify this. I don't know what I'm doing now. The gradient of DF into this becomes -1/2 is equal to -1. Therefore, we can make our conclusion that the gradient of DF is going to be, when we divide by -1/2, we get 2. Or alternatively, we can do this. We can literally use the line DF directly, since we just found the coordinates of F above, and just from the usual calculations. So we would get our 2 marks in there, essentially. Alright, so I don't know why I'm rushing for marks. Anyway, let's leave this one. So there's 2 ways we can do this gradient. We can use that property, or we can just solve this directly. Okay. So what can we say? We can say then, we know that line DF essentially is such that y minus y at D, I can choose point D, is equal to the gradient minus x at D. This implies that y minus y at D is going to be +2. The gradient is 2x minus 4. Implies y plus 2 is equal to 2x minus 8. Therefore, y is going to be equal to 2x. Transpose that 2, we get -10. That is our equation. Nice and easy. So this question is a common question. It's usually easy marks, guys. You must always get it right. There's no excuse for getting it wrong. So we're getting 4 marks. You see, here you're getting a reward for very little. Most likely we get a mark for finding the gradient. We get a mark for calculating the gradient of OD, okay? And essentially doing correct substitutions of point D into the correct format and the answer, okay? That's how we can score those 4 marks. But if you chose this direct route for this step, you get a mark, and for that you get a mark, and the substitutions and the final answer. So however you want to do this, this is your option for finding the gradient of that tangent. All right, let's move on. 4.4. We need to calculate the value of t, and then again it says show all your workings. So this means we need to show all the steps. So how do we do that? Well, we can use the fact that the line DF is perpendicular to that radius. So we can use that property again. So we can say MGF multiplied by MDF should give us a minus 1. Why? Because the tangent is always perpendicular to the radius of a circle it touches. Great. Now we need to display the expression for that gradient of GF. We can use point G as reference, so it's going to be 0 minus 6 divided by T minus 8. Now multiplied by the gradient of DF from above is 2 is equal to minus 1. Alright, so this also implies that maybe let's just do the gymnastics of note, so we can divide by 2 such that we've got 6 minus 6 actually over T minus 8 is equal to minus a half. Then we can cross multiply such that we get minus 12 is equal to minus T plus 8. Therefore, transpose T to the other side, it becomes positive. Transpose 12, we get 20. So that is our answer for that calculation. Or alternatively, we can actually use what we realized, that this OD is parallel to FG, and essentially suggesting that their gradients are the same. And now we know the value of the gradient of OD because we have used it above here. Can you see certain calculations become your absolution? And we literally have to justify this statement. We can say DF is parallel to GF. How? Because we can clearly see that this angle GFD is equal to FDO equal to 90 degrees. And these are the alternate angles. So when alternate angles are equal, it means two lines are parallel and they are cut by some transversal line. In this case, the tangent. Can you see here? What is key though is that the final common pathway is often easy to see. No matter what technique you explore, you almost always come down to the same common final pathway. Either way, we are getting how many marks for this? Just 3 marks. So essentially we can say here we are going to get a mark for correct substitutions and for the answer and perhaps for that expression. Perhaps that's how those 3 marks are scored. Or if one does this, this is a powerful statement and essentially the general substitutions there and the final answer gives us the mark. So there's many ways in which you look at some questions. So please guys, keep your eyes opened because there's no excuse honestly for not getting these marks, but you need to be aware of your diagram better. It's like some kind of a health related issue. If you are not aware, you will only see when you have it and it has destroyed you. But those who are aware, when they see some signs, they go and get them checked out, then they solve that problem before it destroys them. So this is essentially the same concept in maths. You need to be aware of what you are given while you keep the knowledge of what you were taught, and essentially it can succeed. It can help you succeed in your attempt at any form of exam that you may have to face to progress. Okay, 4.5 says determine the equation of the larger circle in this extended format. Okay, not a big deal. So we know that essentially the circle with center G is such that we take x and subtract the x coordinate at the center, plus y, we subtract the y coordinate at the center, is equal to r squared. Now we know that point F lies on that circle. So we substitute 8 minus 20 squared into 6 minus 0 all squared is equal to r squared. We can say here, therefore our r squared is going to be, that is 144 plus 36, that's 180. Okay, we can say then circle with center G is going to be x minus 20 all squared plus, now y minus 0 is just y squared, is equal to 180. This implies we extend this, it's going to be x squared minus 40x plus 400 plus y squared minus 180 equal to 0. Therefore, we try to put it in the manner that it is required x squared plus y squared minus 40x, and 400 minus 180 is plus 220 equal to 0. So we have put this equation in the format required. So essentially this first expression is important, the necessary substitutions and finding r squared is the third mark, and then the fourth mark is literally extending that equation into the format that is essentially required. So this was easy 4 marks. Now let's do the last question. So 4.6, which is the main question. Now it says the smaller circle must be translated. Now a translation is a shift by k units, okay, along the x-axis. Can you see? If we shift something horizontally, it means it's a horizontal translation. But now to which side? We are taking the smaller circle to touch the larger circle internally. So this means we're moving this circle to the right horizontally. So it's a horizontal translation. Now we are to calculate the possible values of k, meaning this amount of units we're supposed to move that across. Now let's look at this, guys. So technically, if we want to see these circles touch internally, this is what we need to see. So literally, we are suggesting that we are moving this circle into the bigger circle so that they touch internally. It can be here or it can be there. Choose a brighter color perhaps. It can be there, isn't it? So now what have we done? If this is the case, it means we are moving this point of the circle. We are literally moving that x-intercept into this one. So basically, our k is that one. We are moving this k units to the other one. So that is basically the first value of k. But what are the coordinates of that point? Now we need to try and determine them. This x-intercept, how do we find the coordinates? Now look, we were given the equation r squared is 20. Now the square root of 20 is 2 root 5. Now from the origin, the center, if we move 2 root 5 to that side, this means this is going to be minus 2 root 5, or the square root of 20, and the y value is 0. So by inspection, you can just work out those coordinates. But you will need to make some declarations. But what about the other x coordinate? I mean, we also appreciated that technically, for us to get here, it means we moved this point right here all the way across. So what is that? This means we literally moved that point all across to there. Okay, so what are the coordinates here at this point? Let's put it outside. Now, we know that essentially the y value is 0 because that's the x-intercept. But if this is the center 0 and we are moving 2 root 5 units to the circumference, this should be basically positive 2 root 5 by inspection. So you don't need to be performing. So there's no need for crazy calculations, but you can if you don't trust it. That's how it works. So we know that here at G we've got 20 and 0. Now again, what did we notice? We noticed that our r squared came out as our r squared here essentially came out as 180. Now what is square root of 180? This is 36 times 5, so this is going to be square root of 36 times square root of 5, so this is going to be 6 root 5. So knowing that from the center we are moving 6 root 5 units to the circumference, it's going to be basically moving that point horizontally. So this is going to be essentially the square root, it's going to be 20 plus 6 root 5 and 0. Because you see, by inspection you just know what's going on here. You know the radius is 6 root 5. From 20, if I'm moving this 20 to there, that's literally what is happening. So you see, if you are happy and comfortable with your translations, this is what you know. So you don't need to really do some serious calculations that may haunt you if you don't perform them correctly. Again, from 20 we are moving that back to the circumference, so that should be 20 minus 6 root 5, which is the radius, and then of course the y value is 0. So can you see, now we are looking for this other k value because k is this distance. So we are literally asking ourselves, by how much must we move that point to here? It's this k units. So we just literally have to find this distance between this point and that point. At the same time, we are also possibly moving that point to here. So it is also that value k, and literally we need to find that distance so that we can move that point to there. Now we've determined the coordinates by inspection, knowing symmetry, and essentially using our logic. So maths is a logical subject. You just have to. So we can just simply say, look guys, the smaller circle which center the origin, right, is such that the center is 0 is to 0 and the radius is equal to 2 root 5, because that's the square root of 20 units. Okay, we can say from here by inspection, therefore the x-intercepts, right, are going to be such that 1 is minus 2 root 5 and 0, and the other one is going to be 2 root 5 and 0, right? Because by inspection we're using the center and the radius, because this is a horizontal thing. So our lives are pretty easy here. So when you are smart, you just do smart things. We can say also, we know that the circle with center G is such that the center is 20 and 0 and the radius is equal to 6 root 5. That's the square root of 180 from just there. Of course, this is units. Always say that. I don't know what I wrote here. Okay. Now, we can say therefore the x-intercepts are going to be such that, now remember, from the center we're moving 6 root 5 units backward. So this is going to be 20 minus 6 root 5 is to 0. And now from 20 we're moving 6 root 5 to the circumference. Horizontally this is going to be 20 plus 6 root 5 and 0. So that's how you justify what you are doing. Now literally, what do we want? We want k now, which is pretty easy. We can say then k should be in this manner. The first distance is going to be the distance between the circumference of this bigger circle and the circumference of the of the smaller circle in terms of their first coordinates. So it's going to be essentially 20 minus 6 root 5 minus that coordinate there, which is going to be minus 2 root 5. Therefore, our k is going to be 20 minus, this is going to be plus, so it's going to be essentially 4 root 5 units. That's the first solution. We can say or k is going to be equal to this bigger k, the blue one. So it's going to be the point ahead, 20 plus 6 root 5 minus 2 root 5, which is positive there. This is going to be 20 plus 4 root 5 units. So those are the two values for k, and these ones need to come out together. So we get a mark for those units because that's what we're interested in. And essentially this smart determination of our x-intercepts for each was key, because without those we were going to be lost. So can you see, guys, you can make a lot of a difficult job very easy when you are very comfortable with these translations, because these things help you to not really faff around looking for answers in the most difficult of ways, or rather the most labor-intensive of ways. You use logic. Logic is essentially very important. Now, this is easy. How else could you do this question since we are doing translation? You could easily do it the long route. Now I'm just going to quickly show it. So basically, we are going to say the smaller circle with center O is given as this. So you can work it out the standard way and say for x-intercepts, it is such that x squared plus 0 is equal to 20, which implies that x squared is equal to 20. Then we perform our gymnastics. And what is that? We literally have our x equaling plus or minus. The square root of 20 is 2 root 5. Nice and easy. Can you see? These are the x-intercepts. You leave it as that. Okay. Then you can say also the circle with center G is such that we know that we found the equation above as x squared plus y squared minus 40x plus 220 is equal to 0. So we can do the same and say for x-intercepts, it will be such that x squared plus 0 minus 40x plus 220 is equal to 0, which implies that x squared minus 40x plus 220 gives us 0. Now the question is, can we factorize this thing? Well, let's see. What is 220 equal to? Shift fact. I'm getting 2. So this one is giving me 2 squared times 5 times 11. Now this is 4 by 5, it's 20. But now 20 plus 11 doesn't give me 40. It gives me 31. So this doesn't work. 5 times 11 is already a crazy situation, right? It's 55, so we will not get the middle term. Let's just check the discriminant quickly. So minus 40 squared minus 4 into 1 into 220. I'm getting 720. Can I take the square root of that answer? The answer is no, so it's irrational. So once the discriminant is not a perfect square, I cannot factorize. So you see, there's very quick ways of checking. Before you start trying too hard, just check the discriminant of any quadratic. If you get a perfect square, then you know you can factorize. Then you can try your luck as often as you want. So here I know that my x is going to be minus into minus 40 using the quadratic formula. You can't run away from it no matter what. So at times you're stuck with it depending on what path. Can you see this path is becoming a bit more painful? And here we were like and got our answer, but this one is giving us a huge challenge. Let's see, what do we get on our calculator? Minus into minus 40 plus the square root of minus 40 squared minus 4 into 1 into 220 divided by 2. So I'm getting here 20 plus 6 square root of 5, or x is going to be equal to, your time is flying. Can you see certain techniques will destroy your time? This one is basically 20 minus 6 root 5. Can you see? So we're getting exactly the same things that we did by inspection. So at times, remember, some intermediate steps, you can decide how you do them. You don't necessarily have to show a particular calculation. But for the final question, because the question it says calculate the values of k, then you need to show a calculation. So we can say, look, from here then, k is equal to the x coordinate there. So obviously, sorry, let's start with the smaller one. The x coordinate here on the larger circle is definitely the smaller one, because that is bigger than this. So it's going to be 20 minus 6 root 5 minus the x coordinate at that point, which is minus 2 root 5. So therefore our k is going to be 20 minus 4 root 5. Now this is units. Do not forget k is the distance here. Or, now that or is important. K must be equal to, now we're going to choose this bigger one, so it's going to be that point there. It's 20 plus 6 square root of 5 minus the x coordinate at that point there, which is just 2 root 5, which also gives us the value of k being 20 plus 4 square root of 5 units. So this one was a bit crazy and a bit of a rough one, but you can still get your marks here. For those values, you get a mark for working out the x-intercepts on both occasions. It doesn't matter how you go about it. The fact of the matter is that you must get the correct answers. So guys, this is how our lesson ends, with some 20 marks had we been writing this exam. So I hope you guys are learning, and please do give me some feedback if I'm doing less or I'm doing more or maybe too much at times. I need to know those so that I can try to cater this to your needs so that you can get the maximum benefit. Otherwise, my 40 minutes of exploration is over. I hope you guys continue practicing and learning in the best way possible. I'll see you next time. Goodbye.